Alright, welcome you guys. This is Algebra 1A. We'll be talking about patterns and linear functions. Okay, a couple of things we do need to talk about are these two right here. Okay, dependent variable and the independent variable. Now, if you get onto a higher level math class, like statistics, this is the response variable. Okay, and this is the explanatory variable. So in other words, the explanatory is giving out what's supposed to be happening to the response variable. Okay, and the independent variable and the dependent variable were the names for the longest time, but they pretty much have dropped by the wayside just because they're not the best at explaining what's going on right there. Okay, now a function is just basically some kind of function. Well, we would call it f of x in higher level math classes. You guys might call it y. It doesn't matter what you use, just understand that it's still going to be there. Okay. Alright, so it just basically it's like the rule. It's a set of terms being added, subtracted, multiplied, or divided. Okay, so just set of terms. And usually they'll call these like a rule for calculations. Okay, so it's something as simple as that. All right, now the input and the output. The input we will call our domain. Domain, or x's that we plug in. Okay. Alright, and obviously that leaves the output as our range. Or y's or answers we get out. Okay, and one of the last things we're going to find before we start today is going to be a linear function. Okay, now linear function is a certain type of function. It follows in this form: y equals y, or f of x equals m times x plus b. Okay, so you take a number, you times it by the value of x that you plug in, and then you add a number after that. You add or subtract, it's up to you how you want to do it. Okay, all right, we usually call m being slope, okay, and b being the y-intercept. Okay, so those ones are pretty simple, straightforward. Alright, so some stuff real fast. You do have to understand the values do correspond with a table. When you're taking information, you can plug the table in there. So, for example, let's say we did a table, and let's get an actual, there we go. Okay, if you had your table of information, let's say we had this be x, this be y, this is 0, and this is 3, this is 1, and this is 6, this is 5, and this is 18, and so on and so on. Okay, if you actually had to come up with a way to do this, and we've talked about this in the very beginning, okay, m times x plus b. Okay. All right. So right here, I'm going to show you real off the fast of the bat, just how to write this function when you're given a table. Okay. So whenever x is 0, and if x is not 0, you do have to make it 0 for this to work. This right here is going to be your y-intercept. Simple as that. Okay, so I can rewrite this as plus 3. Okay, because I definitely know that number. All right. Now, whatever the distance is here, this is plus 3 here, you divide it by the distance here. Okay, so in this case, it would be 3 divided by 1. Okay, that number is going to be your slope. Okay, now if you use different distance, for example, this one's much greater. This is plus 4. Okay, and this is plus 12. Okay, you would still do the same thing. You would just divide. So 12 divided by 4 is going to be reduced to 3 over 1, which is the same as m. Okay, so as you can see, no matter where I go in here, when I'm messing with the numbers, I can actually calculate that. So now I can write the rest of the equation as y equals 3x right there. And then I already have the plus 3, so wham, I can actually write the actual function. Now if I wanted to test it, okay, let's say I wanted to test what happens if I plug in 7, what do I get out? Okay, let's say we had something like that. So if I plugged in 7, I would take the equation and go 3 times 7 plus 3, and just do my calculation real fast. Y equals 21 plus 3, which is 24. Okay, so the number that should be going here is 24. So if for example, I'm ever like tested with the idea of okay, which table matches this whichever function, you would just see which information matches up. So you would have to plug in your inputs and then check it with your outputs and see if you get the same amount of numbers. Okay, all right, and we would also have to check, like, what, let's say 9 and 30, is that a result? Does that work? Now let's say 31. Okay, so we take 9, we plug it in, so y equals 3 times 9 plus 3, okay, and we get y equals 27 plus 3, which is 30. It should be 30, okay, so this result is not correct, so we would actually say no, that does not work. Okay, so now also another interesting fact is that if we were to graph this out over a coordinate plane, okay, our first dot, well, let's say we actually make our coordinate plane, so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's not the best drawing in the world, but once again, this is drawn with all hand. And apparently a hand that was shaky and jittery with coffee this morning. Okay, so when we graph the actual points, we start here with 0, 3, so we would put a dot at 0, 3. Okay, so we would move this up to right there. Okay, and then if we wanted to do 1, 6, we would go right 1, up 6. Okay, and if we wanted to do 5 and 18, we would go over to 5, and then we would, if you have to, you actually have to extend this line. Please do. Don't feel bad about extending it if you're not given enough information. You know the pattern and what it does. Okay. Okay, so 1, 2, 3, 6, 7, 8, 9, 12. What is that? 12, 15, 18. Yep, that works. Okay, now if you've done everything correctly and you've drawn your graph semi-legibly, okay, you should have this pretty much lined up. As you can see, my graph spacing is all out of whack, so you can tell that based upon it, my line is not going to be straight. Okay, it's not going to be making the linear pattern that I need. Okay, but if it was correct, let's just say I moved everything over and adjusted accordingly, it should make a straight line. Okay, and always check it by drawing a straight line through it. Not a big circle like I accidentally just did, but an actual line. And as you can see, they all should line up on that pretty close. Okay. All right, that's it for functions and patterns in linear functions. So I'll talk to you guys later. Bye.